This is a video series about really understanding computer code and becoming an actual programmer. It's for people who know how to write small programs using basic language features like variables, lists, print statements, if statements, and loops, and who have probably watched a number of programming tutorials, but who still have trouble knowing where to start when it comes to writing a program from scratch. We'll use C++ in this version of the video. If you want to see it done in Python or JavaScript, there are separate videos that are the same as this one but using those programming languages. It's a great learning experience to see a problem solved in multiple languages. You'll find that programming languages are more alike than different. When you know one or two programming languages, you kind of know them all in a fundamental sense. Along the way, we'll build up a set of mini patterns that I call pro tips, which are principles or rules of thumb that can be used in solving a wide variety of problems in any programming language. Let's start with a terminal program that inputs a number and prints a pyramid of stars. We'll assume we have a C++ compiler already set up. When I refer to an exe program, it means a program we've compiled. There is a separate video in this series about setting up C++ build tools. The program we are building is pyramid.exe, so if we compile and then at the terminal we run pyramid.exe, it asks us how many rows in the pyramid. If we enter 4 and press enter, the program prints a 4-row pyramid of asterisks. If we input 2, it prints a 2-row pyramid. If we input 6, it prints a 6-row pyramid, and so on. Let's put the sample output with 4 rows on the side here, so we can refer to it as we work on this problem. Now, you might have some programming experience and you might be able to write this program straight off. In fact, whatever your programming level, you might want to pause the video and take a moment to see if you already know enough to solve this problem. Now, if this were a typical tutorial, I could calmly write out a solution with a bit of explanation as I go. But let's suppose we don't know the solution right away. How do we start? Well, first of all, we have to ask the user for a number on the terminal. Because of how C++ evolved historically, there is a bit to understand here. First of all programs need a main function, which will be run when the program starts. For this exercise, we'll put all of our code inside main. We return 0 from main to indicate the program completed without error. This line prints our prompt, how many rows, on the terminal. This line declares an integer variable n, and this line waits for the user to type some characters followed by the enter key, and converts those characters to a number that it puts in n. This include statement makes the IOStream library available, which is where we get cout and cin. The preferred way of outputting text to the terminal and inputting values from the terminal is one area of C++ that has changed a lot over the years. Because exercises like our pyramid problem involve writing to and reading from the terminal, it means beginners need to deal with these complexities right up front, including the overloaded bit shift operators, the double angle brackets, for inputting and outputting text. But as we'll see, most of the C++ language features we'll use are not as quirky. Okay, so we have the user's number in a variable n, and we have to print a pyramid of n lines. So it seems like we're going to need a loop, and each time through the loop, we'll print a line. We can see a pattern in the output. Each line starts with a certain number of spaces, followed by a certain number of stars. Each line has 2 more stars than the line before it. As for the spaces, the first line starts with 3 spaces, and then the spaces are reduced by 1 for each subsequent line, till there's 0 spaces on the last line. So we have a growing number of stars and a decreasing number of spaces. We have a loop, and our for loop variable I counts from 0 up to n-1. Like if the input n is 4, the I in our loop would be 0 the first time through the loop, then 1, then 2, then 3, then the loop is done. So it seems like we have to come up with some formula, some code expressions, to convert our loop counter I into a number of spaces and a number of stars. But it might not be immediately clear what the formula is. We might feel overwhelmed with having to come up with code that will compute the right values and at the same time generate the desired output, the actual spaces and stars, to print on the screen. We might be tempted just to guess at some expressions involving I, maybe I plus 1 or I minus 1 or I times 2 or n minus 1 or n minus I plus 1 or something like that, and then tweak the code, adding or subtracting 1 here or there until we get the right output. We might think, a real programmer would just know these expressions, but I can only guess at them. Well, to make ourselves feel better, we can introduce our first pro tip. Solving a simpler problem can sometimes bring you closer to a solution, or at least help you understand the problem better. So how can we make this problem simpler? How about if we printed just the stars and didn't worry about the spaces? Or actually, how about if we just printed one star on each line? Now that we know how to do. We just print one star each time through our loop. Okay, let's run the code. We input 4 rows. All 4 stars came out on one line. If we check the documentation for cout, we see that it does not automatically add a new line character to the end of the output. This is different from the default behavior of Python's print function and JavaScript's console.log function. So to get each of our stars on its own line, we need to add a new line character to our output. The endl value in the standard namespace holds the new line character. We run the program again, and there we go. We printed 4 lines with 1 star on each line. A small victory, but we'll take it. Now how can we print the right number of stars on each row? The truth is that even an experienced programmer would have to stop and think for a bit about how to compute the number of spaces and the number of stars from the loop counter I. The programmer makes a table like this in his or her head, with special focus on the first row when I is 0. With this table, we can see that the first time through the loop, when I is 0, we want to print 1 star. And each time through the loop, we need 2 more stars. So somewhere in there it seems like we need I times 2. But if we just multiplied I times 2, we'd get 0, 2, 4, 6 stars. Those are all 1 less than the desired values. So if we add 1, then for I equals 0, we get 0 times 2 is 0 plus 1 equals 1. That's good. For I equals 1, we get 1 times 2 is 2 plus 1 equals 3. That's good. For I equals 2, we get 2 times 2 is 4 plus 1 equals 5. That's good. And for I equals 3, we get 3 times 2 equals 6 plus 1 equals 7. Great, that expression seems to work. Let's put it in the code. Okay, so now we know how many stars we want to print, but how do we actually print that many stars? If you watch the Python version of this video, you'll see that we use Python's built-in ability to multiply a string by a number to make a new string with that string repeated. And in the JavaScript version, we use the built-in string repeat function to do the same. C++ doesn't have either of those built in exactly, but if we check the documentation for the string type, there is a string constructor that lets you repeat a single character any number of times. That happens to work for us in this problem because we just need to repeat the single star character n times. We'll talk more about constructors in other videos, but for now, understand that by using the arguments of 3 and the star character, star string is built as a string with the star character repeated 3 times. So let's use that constructor in the code. Okay, we run it. We input 4. Yes, we got it. By the way, suppose we didn't know about that string constructor that repeats a character. Or suppose we wanted to repeat a string with multiple characters, not just one. In that case, we'd need to use a subloop, like this one, to build up our string. We start with an empty string, and loop num stars times, adding a star to the end of the string each time. Let's run this code to see that it gives the same result. Yes, it works. Because the repeated character string constructor is available, let's use it, because it simplifies the code for this particular program. But it's good to know that we could manually repeat a string with a subloop if we needed to. We're close to the solution of this pyramid problem. We just need to print the right number of spaces before each row of stars. We found a formula for the number of stars using a table. Let's add a spaces column to the table with the heading S. When I is 0, we need 3 spaces, at least for our sample 4-row pyramid. Then each subsequent row has 1 fewer space. Again, the key is to focus on that first row when I is 0. For the 4-row example, the first row has 3 spaces. With a bit of thought, we can see that the number of spaces for the first row is always n-1, so that we always get down to 0 spaces on the last row of the pyramid. Here, it's 4-1, and if we were making a 5-star pyramid, we would need to start with 4 spaces, which is 5-1. So let's start our expression as num spaces equals n-1. Then, as our loop continues and I increases, we need to subtract spaces, subtracting 1 when I is 1, 2 when I is 2, and so on, which means we always want to subtract I from our initial n-1. There it is, we found our expression. Let's put it in the code. We can easily extend our print statement to print the spaces before the stars for each row. Let's see how it works. Run the program. Input 4 rows. It works. That's great, but we should always check that our code works for a range of inputs. Let's try 5 rows. Looks good. Let's try 2 rows. That looks good. Let's try 1 row. Yes, just the 1 star. Let's try 0 rows. That's right also, it prints nothing. Let's try 15 rows. That looks good too. We've completed the program, but there's something about this solution that bothers me. As you gain more experience in programming, you develop an inner voice, an inner critic, who tells you that even though your code may be working, it could be improved. In this case, the voice is telling us that these 2 expressions we developed for the number of spaces and the number of stars took a bit of time for us to work out. And if it takes time for us to think of them, then it's going to take time for someone else to understand this code later. And even when we ourselves come back to this code later, we might not remember how we got these expressions. It's not that these are the most complicated expressions in the world, but our goal as a programmer should generally be to write the simplest code possible, unless there's a specific reason not to. We can put in comments explaining how we got these expressions. That helps a bit, but it adds wordiness, and it doesn't really change the fact that the expressions are somewhat complicated to think about in the first place. In fact, let's capture this as a pro tip. Code that is tricky to write is tricky to maintain, and if you need a comment to explain code, see if you can simplify the code so the comment isn't needed. Let's step back and consider whether we can solve this without these somewhat complicated expressions. Let's stare at the code. The answer is that we can use variables to keep track of how many spaces and stars a line should have, instead of computing the number of spaces and number of stars from scratch each time through the loop. We can just start these variables at appropriate values and modify them each time through the loop. So before the loop, let's start our variable numStars at 1, because our first line has 1 star. And we'll start a variable numSpaces at n-1, because the first line has n-1 spaces, as we saw. Then in our loop, after printing the line with numSpaces spaces followed by numStars stars, we simply change the 2 variables to prepare them for the next iteration through the loop. So we add 2 stars and subtract 1 space. And this all replaces our 2 computations, which makes our inner code critic happy. Okay, let's see if it still works the same. Input 4 rows, and there it is, still works. Let's try 2 again. Looks good. Let's try 5 again. Looks good. In my opinion, this code is easier to read without those expressions. We can state what we did here as a pro tip. There's often a choice between using state variables versus computing from scratch each time. Counter variables like numSpaces and numStars, as used here, are an example of state variables because they keep track of the state of the program. It's often a matter of taste as to which approach is better, but as we saw, state variables often lead to simpler code because we just need to modify them as they change instead of computing the needed values from scratch. The downside of state variables is that if your state variables get messed up, like if you mistakenly increment a state variable somewhere in your program, it's easy for your whole program to get out of sync and stay out of sync for the duration of the run. Thanks for accompanying me on this problem-solving journey. But remember that you become a programmer through practice by writing your own programs. You'll need to have a C++ compiler set up and working. There's a separate video in this series about setting up C++ build tools. Here are 4 follow-up exercises for you to try that reinforce the concepts we covered in this video. You'll also find these exercises in the comments below. Number 1. Write a program called block.exe that inputs a number and prints a block of stars, a solid square of stars. Just like that. Number 2. Write a program called square.exe that inputs a number and prints a hollow square of stars. Just like that. Number 3. Write a program rectangle.exe that inputs 2 numbers and prints a hollow rectangle of stars. Like that. 4 stars wide and 6 stars high. Number 4. Input a number and print a hollow inverted pyramid with that many rows. Yes, this one's a bit more challenging, but don't worry. Start with a solid inverted pyramid first. Okay, good luck and have fun coding these.